Alright, ladies and gentlemen, let's have a little lesson about how to graphically add and subtract complex numbers. So, in comparison to the things we were just doing, which is like polar coordinates for complex numbers or just polar coordinates in general, this is loosely related, but not quite the same thing. It doesn't come into play when you're adding and subtracting complex numbers. It does come into play when you're multiplying complex numbers, which will be the next lesson. But let's go over how to add and subtract complex numbers graphically. So if you remember, to graph a complex number like -3 plus 2y, we have your real axis and your imaginary axis. So you're going to go left 3 and up 2, and then you draw the vector that goes from the origin to that point. So that's how you graph the first one. If you then want to add another complex number onto that graphically, say 1 plus 3i, you go to the end of the vector you just drew, and then you draw your new vector starting there. So 1 plus 3i would be going right 1 and up 3. So I can go right 1, up 3, and I draw my vector that goes there. So if you put these vectors end to end, that shows what the end result is going to be when you add them graphically. And so now that we have those, your final answer is to go from the origin, draw a vector from your origin to that point you just ended up at. So that's why there's this thicker vector that goes there. That's the result. That's the answer. We have graphically added these vectors. Nice. Well, if you want to subtract complex numbers, you still draw your first one like normal. So if we got -3 plus 2i, it looks like that. And then if we wanted to subtract 1 plus 3i, instead of going right 1 and up 3, you do start at the end, but then you go the opposite direction for both, right? So instead of going right 1, you go left 1. Instead of going up 3, you go down 3, right? You subtract the vector, and you see here it's got a little dashed line here to show that subtracting. When you get that point, you're going to draw the vector from the origin to that point, and that end vector, last one you draw, this big thick one, is the result. That's the answer to subtracting these two vectors. And that's pretty much it. That's what's going on. So let's go ahead and do that. If you're looking for spelled out steps, here's a bunch of spelled out steps for you. But let's go through the process of adding these two vectors. So adding these two complex numbers, which we could represent with vectors. So the first one here is at 5, -2. So I'm going to write it in vector notation. And I'm going to add on -2, 4. Like that. And so with the first one, go for my origin, right 5. 1, 2, 3, 4, 5. And then down 2, because it's -2. That was not very straight. But luckily I have a straightening tool on my iPad. Yeah, it goes like that. And next I need to take this vector and I'm going to draw it, but starting at this endpoint. So I got this point, and I need to go left 2 and up 4. So I'm going to go left 2, up 4, 1, 2, 3, 4. Gives you here. And now I have my second vector. Remember, you do it end to end. So you go to the end of the arrow, and then you start next vector. Now we have that. This is the result. We're going to draw a vector from our origin to that point, and I'm going to make it thicker to show that that's the resulting vector. That's where it ended up. And so, ta-da, we have graphically added these vectors. If you also wanted to write it out as a complex number, which is what it has here for part 4, you just take your components, you add them up. You can figure out the components of your resulting vector. That's right, 3 up 2. So it's 3, 2. Which should be no surprise, because 5 plus -2 is 3, and then -2 plus 4 is 2. So that's the vector, but if you want to write it as a complex number, you just convert it to complex number by doing 3 plus 2i. So there we go. We have added these vectors together, added these complex numbers graphically. Okay, we're going to go through the process again to subtract a couple of complex numbers. I'm going to convert both of these to vectors and go through the process of graphically subtracting them. So negative 4 minus 2i becomes negative 4, negative 2. And you subtract, vector. 2 minus 3i is 2, negative 3. And that's what I'm going to be graphing. It's on the next page here, so I'm going to just kind of copy and paste it so you can have it all on the same screen here. Paste, and put it here. Okay. So now I'm going to graph my first vector, which is negative 4, negative 2, which is left 4, 1, 2, 3, 4, and down 2, 1, 2. So I got my first vector from my origin to negative 4, negative 2. And then I'm going to graph my next one, which is 2, negative 3. I'm going to start here at the end. But I'm going to go the opposite of these directions. So it's almost like I'm changing the signs here, like adding negative version here. So adding the negative version of it. So I'm going to go left 2 and then up 3. So left 2, 1, 2, 3, up 3. So instead of, and I'm going to do this as dashed line as well, just to kind of show you that it's subtracting. If you were to do this with the positive one, right, it'd be right 2, down 3. That'd be the positive version, but we're trying to subtract it, so we're going in the opposite direction. So now we have that. We have this endpoint over here. We're going to draw a vector from our origin to here and put an arrow. And again, I'm going to just kind of thicken up this line to show that that is the answer. Make a fuzzy vector that goes here. Hooray, we got it. And now that looks just absolutely terrible. Here, let me try and fixing it. Right? Go like these, go like these. Alright, less scary. Okay, now we're also going to write the answer to this as a complex number, which, if I look at my graph, it went left 1, 2, 3, 4, 5, 6, and then up 1. So you should be getting 6 plus, or 6, not comma, 6 plus 1i, or it's just 6 plus I, which should not be, it's left 6. I'm going to put negative 6 there. Sorry. Left 6 up 1. So negative 6 plus 1i, which shouldn't be a surprise because that's what you get when you do negative 4 minus 2, and then negative 2 minus negative 3, you get negative 6 and then positive 1. So hooray, we wrote a complex number, we graphed it, and that's it. So that's what's going on your assignment. You just go through and you graphically add and subtract these complex numbers, and it should be a piece of cake, really, in comparison to what we've been doing. So good luck, and may the force be with you.